On April 24, 1990, the Space Shuttle Discovery launched the Hubble telescope into orbit, marking an exciting milestone in space exploration, with the promise of groundbreaking images of the universe. Over its 30 years of service, Hubble has delivered on this promise, capturing millions of astonishing pictures and becoming the most renowned telescope globally. However, its success was almost thwarted by a critical flaw in its mirror, which initially rendered it nearly useless. Despite this setback, Hubble's remarkable contributions to our understanding of the cosmos stand as a testament to its resilience and significance in advancing human knowledge of the universe. Welcome to my channel. Before starting, don't forget to like and subscribe to our channel for more future updates. So, let's start. Shortly after its launch, scientists detected a minor flaw in Hubble's mirror, causing severe image blurring. Measuring 2.5 meters, this mirror serves as the core of the telescope, crucial for generating high-quality images. Light captured by the main mirror reflects onto a smaller mirror, then onto various imaging instruments. Ideally, light hitting any part of the mirror should converge to the same point, but the defect diverted light, resulting in distorted images. Despite a minute deviation of only 2,000 nanometers, this flaw rendered Hubble non-functional. Surprisingly, a backup mirror, built and tested alongside the main mirror, was available but remained unused. The oversight in deploying the flawed mirror into space stemmed from a failure to cross-examine both mirrors for potential defects. This incident underscores the meticulous precision required in space missions and highlights the critical role of quality control in space exploration endeavors. In 1977, NASA embarked on the construction of the Hubble telescope, allocating approximately $300 million for the project. Opting for cutting-edge technology, they enlisted the expertise of Perkin-Elmer, an optics company, to design and fabricate the telescope's main mirror. Perkin-Elmer's selection was based on their proposal to utilize custom-built computer-controlled polishing machines, capable of achieving the required precision of just 10 nanometers. As a precautionary measure, NASA also subcontracted Kodak, renowned for its optical expertise, to manufacture a backup mirror. Despite Kodak's suggestion to cross-examine both mirrors for defects, this precaution was overlooked. With funding secured, Perkin-Elmer commenced mirror production in 1979, meticulously shaping a blank sheet of ultra-low expansion glass over 2 years. The resulting mirror, coated with reflective aluminum, marked a crucial milestone in the Hubble telescope's construction, despite the missed opportunity for comprehensive quality assurance. Over the next few years, the mirror went through a series of tests to show that it could handle the intense vibrations of a rocket launch and survive the harsh conditions of outer space. But in order to test if the mirror had been polished to the correct shape, they used something called a null corrector. This was essentially a special lens with a series of mirrors, used to make sure that the light hitting Hubble was being focused correctly. A laser was shined through the null corrector in a lens, which contained a wavefront. If everything was perfect, the lines from the wavefront would look perfectly straight with no contour lines. However, as the engineers were setting up the null corrector, one of the mirrors was wrongly positioned, and it perfectly canceled out Hubble's flaw. This caused the results to show that Hubble's mirror was, in fact, perfect when it most certainly wasn't. At the same time, Kodak was nearing the completion of their mirror, but since NASA had chosen to go with Perkin-Elmer, Kodak's mirror was left without its reflective coating and put into storage. This tiny error made its way through the testing program, and in 1990, the telescope finally launched. It didn't take long for the scientists to realize that something was very wrong. The first images received from Hubble were blurry and clearly showed that the telescope was not performing correctly. For the engineers, this was a crushing blow. After decades of work and billions of dollars, it seemed like Hubble was going to be remembered as the most embarrassing space project in the world. To add to the misery, the backup mirror made by Kodak was tested, and the results showed that it had been polished to the correct shape. If Perkin-Elmer had agreed to cross-examine both mirrors, it's likely that the mistake would have been found before Hubble launched. Despite the Kodak mirror being perfect, it was essentially useless since replacing the mirror in space wasn't really an option. However, Hubble was specifically designed in a way to be repairable. Located in the back of the telescope were Hubble's 5 instrument bays. Each bay has a box which contains a scientific instrument, allowing Hubble to take various kinds of measurements. This modular design meant that instruments could be taken out and replaced by more advanced instruments throughout Hubble's lifetime. so Mesa began working on an ingenious solution that could fit into one of the instrument bays and repair Hubble's faulty mirror. Although the polishing machine had made a mistake, it made a very accurate mistake, so Mesa knew exactly how wrong the mirror was. They came up with a compact set of mirrors and lenses that would take the light and refocus it onto Hubble's various instruments. This new instrument, called QSTR, featured two small mirrors that extended out from the instrument. One mirror was completely flat and simply reflected the light onto mirror 2, which was curved in the exact opposite way to Hubble's main mirror. This put the light back into the correct form and focused it onto the instrument. After $50 million and 2 years of development, QSTR was ready to be launched. On December 2, 1993, a pivotal mission was launched aboard the Space Shuttle Endeavour, carrying 7 astronauts tasked with rescuing the Hubble Space Telescope. Equipped with the Corrective Optics Space Telescope Axial Replacement (COSTR), the team embarked on a daring 7-hour spacewalk to execute the critical repair operation. With precision and care, astronauts removed one of Hubble's malfunctioning instruments, seamlessly replacing it with QSTR. Despite encountering challenges that prolonged the deployment process over several weeks, the perseverance of the crew paid off when Hubble transmitted a set of astonishingly clear images back to Earth. These images served as undeniable proof that the repair mission had been a resounding success, reaffirming Hubble's capability to continue its groundbreaking observations and cementing its status as an invaluable asset to the scientific community. The scientists behind the Hubble telescope celebrated a significant achievement as the instrument was finally able to fulfill its intended purpose. Over the ensuing decades, Hubble embarked on a remarkable journey of exploration, unveiling breathtaking discoveries and offering unprecedented views of the universe. Regular servicing missions by the Space Shuttle ensured the telescope's longevity, with the removal of QSTR in 2009 marking a milestone in its operational evolution. Meanwhile, the pristine Kodak mirror, though never utilized, symbolized a missed opportunity for cost-saving and efficiency. Despite the challenges faced, the successful repair of Hubble underscored humanity's ingenuity and determination in overcoming adversity. As Hubble's end draws near, its legacy as an emblem of scientific achievement remains indelible, paving the way for future telescopes equipped with even more advanced capabilities while honoring the wealth of knowledge gleaned from its decades-long mission. This is it for today's video. What do you think of our video? Feel free to share your thoughts in the comment section below. Don't forget to like and subscribe to our channel for more future updates. Thanks for watching.